Hello everyone. Now I'll be discussing about the practical, that is to simulate the layout of a multiplexer. The objective is to prepare layout of multiplexer using CMOS and transmission gates, simulate and verify the output. And you need to have PC with Microwin 3.1 or any other higher version installed. This is the logic diagram for a 2:1 mux. So the first diagram, if you look at, it is made up of transmission gates. So two transmission gates are needed to make out the 2:1 multiplexer, as we need to pass the two inputs. This is the A and this is the B. So selection will be like here S and S bar. So normally the expression for a 2:1 mux is A S bar plus BS. So for the same expression, that is A S bar plus BS, here you can see this is the logic diagram for the conventional method, that is using CMOS method. So we need to have both the P channel MOSFET as well as N channel MOSFET. As we all know, with the CMOS, when we make any structure, it will be the inverted form. But since we want non-inverted form, that A S bar plus BS, we need to connect an extra inverter here. So totally you can see, now this inverter will have one P channel MOSFET and N channel MOSFET as well. Here I have made use of 4 PMOS and 4 NMOS. So total transistor count is 10, where 5 are PMOS and 5 are NMOS. So the logic is quite simple. When the selection input is 0, output will follow A, and when the selection is 1, the output will follow B. So this is the layout for the 2:1 mux using the transmission gates. See, transmission gate is made up of again the both P channel as well as N channel MOSFET, but it acts as a switch. There is no supply to it. And this is the layout diagram for 2:1 mux using CMOS. And this is output waveform using the transmission gates, where you can see when S is 1, the output should follow. Here you can see the output should follow A. You can see here. When S is 0, the output is following A, and S is 1, the output is following B. Okay. Similarly, here you can see for CMOS, using CMOS, when S is 1, the output is following B here, and when S is 0, the output is following A. Okay, now I will show you how to prepare the layout and how to do it. So for this, I'll start Microwin. Microwin is the software which I told you. So I'll prepare the layout for transmission using 2:1 mux using the transmission gates. P channel and N channel. So this is well. Then I need to place polysilicon gate for making the gate structure. Now here I'll be combining with the metal. See, since for P channel we need to have angle, I'll draw an angle here. Okay, now similarly make one more transmission gate. That is good one. Make the gate structure. using the metal and then the same contact, the same contact. Take the contacts. Then here I need to place again the angle. Polarize it. Now we need to take the output. So I will take it like this. So this will be my output. I'll place it here and make it as Y or Z, any name as per your choice. And I need to give the selection. So for giving the selection, just connect these two together. Then I can start this to place contact here, the contact here. So if this is S and this will be S bar. Okay. So here I need to make the contacts. Here I need to make the contact. Start this. So now it's looks okay. Now I need to give the inputs. So this is the input A, which I need to make, and then apply input B, and apply the selection. So if I take this as S, then this will be S bar. So I just make last block. This will be S bar. Now you can observe. The waveform. So when S is 1, it is following B, and when S is 0, it is following A. I'll invert this so that we can observe here. I'll make this S bar, and I'll make this as S. We'll get it exactly what we want. See here, you can trace out and see when S is 1, it is following A, and when S is 0, it is following B. Okay, so this is what we are supposed to verify with the multiplexer. Fine. Now, once you get this, you are supposed to take the screenshot of this. Take the screenshot of the output waveform. Take this layout diagram, and you are supposed to submit it when with the write-ups. Okay, you can see the 3D image also. So similarly, you can make out the layout of the combinational, that is the marks using conventional method, that is CMOS method. Now I go to new. I don't want to save it. You can save it at your home. Now I need to make it using AS bar plus BS equation. So for AS bar, first I will place the P diffusion, then I will place the N diffusion. Now I need to have the polysilicon one is for S bar, one is for A. So this makes me A S bar, and this is for E, and this is for S. Okay, so now so here anyway I need to make inverter. I'll make it right now here itself. I'll make an inverter also. So the metal you are supposed to take the output. Here is the actual output. Y. See how we are supposed to make the inverter. So I am making the inverter first so that I can join it easily. I am giving here VDD and giving here VSS that you all know. Here is your supply N plus N point, sorry, this is P plus N contact, right? So this is P plus N contact, this is N plus N contact. Now I need to pass the output from here to here. Okay, so since this is AS bar plus BS, what I need to do is I need to make them parallel. So I take the metal line and give here VDD. So this will make this AS bar. So I give here itself this as A, and this will be S bar. Anyway, I want to invert, so I will give it later. And this is B. And now these two structures are to be made parallel. So with the help of metal, take the parallel lines, and VSS I need to do. I'm taking here, extend this, so that I can draw here within the metal line. So this is F plus and metal, F plus and metal, P plus and metal. And this has to be taken, these two has to be made in parallel. Okay. So now drawing this here. Sorry, I forgot to the angle. Metal has to be given here. And that is here outside. So this has to be reversed. Now this I need to connect here as the input. The output of this has to be connected as input here, so that it will be in non-inverted form. Now VSS is given here, so my circuit is complete. Only thing is I need to give selection input. If this is S, then this will be S bar. Last clock I will say, what last clock. Awesome. Now run the simulation. So see here, when S is 1, it is following A. When S is 0, it is following B. Clear? So this is how you can verify both. But here if you see, the power delay of CMOS method is 0.963 microwatt, whereas the power dissipation using transmission gates will be 0.